Okay kids, after a couple of weird technical difficulties, I'm going to start this homework, but I already started it twice and I had to erase the video because I'm not awesome with technology, so just bear with me. Over here, I've written the conversions for Celsius and Kelvin. They're going to be important for you to remember. 273 is the magic number that gets you 2 Kelvin or 2 degrees C, but it's such a weird number it's easy to remember. Standard temperature is 0 degrees Celsius. Or you could say standard temperature is 273 Kelvin. For this number 3, you're converting Kelvin into Celsius. So which formula do you think I would use? Well, if I want degrees C, I'm going to use the one that ends up in degrees C. So I'd plug 105 in here, so it would be 105 minus 273, and that's going to give me my temperature in Celsius. 105 minus 273, excuse me, that number right there, negative 168 degrees C. Number 5, we're converting 32 degrees C to Kelvin. Well, if I want Kelvin, I'm going to use this formula right here. I'm going to put 32 degrees C plus 273, and that's going to give me Kelvin. So 32 plus 273. Liters is volume. If this gas is brought back to a lab where the pressure is 1.1 atmospheres, so we know that's a pressure, and the balloon becomes 4.75 liters in volume, what was the original pressure of the gas? Well, in this case, it's easy to see what I'm calculating. It's asking for original pressure, which would be my P1. So P1 is my unknown. You can use X, you can use question mark, whatever you'd like. My initial volume, it says that the sample was collected into a balloon or into a 0.750 liter balloon. And once you get it back to the lab, it increases in volume. So that's my initial volume, and that is my final volume. So V1 is 0.750 liters. P2 is the other pressure, 1.1 atmospheres. And my V2, my final volume in the lab, 4.75 liters. So we're going to plug these numbers, these variables right here, into my formula. P1 is still my unknown, so I'll leave that alone. V1 is 0.750 liters. I'll set that equal to, because that's my formula, equals P2, so there's my P2, 1.1 ATM, times my final volume, 4.75 liters. Okay, so the way to solve this problem, I need to solve for P. So I need to get P by itself. First thing I'm going to do is multiply these numbers together right here. Okay, 1.1, oh goodness, 1.1 times 4.75 gives me 5.225. So far I have P1 times 0.750 equals 5.225. Okay, I need to get P by itself. What do you think I should do? I'm going to divide both sides by 0.750 because I want P by itself. So I divide that by 0.750. 724,648 equals P2 times 942. So how do I get P2 by itself? Divide both sides by 942. So take that big number that I had, divide it by 942, and I get 769.26. I think 769 is adequate for us. 769. P2 is a pressure unit. Pressure, in this case, is in millimeters of mercury, not atmospheres. Okay, that's okay. So we'll put it as 769 millimeters of mercury. So that was lesson number 1 for the week of March 30th.